this lesson, I'm sorry, is area and perimeter of triangles. So we want to be able to calculate the perimeter and the area of a triangle given the side lengths and or the altitudes. So the formula for area is base times height divided by 2, and the perimeter is you just add up all the sides, A plus B plus C. Now remember, the height has to be perpendicular to a base. So in this picture here, here's my base, because there is where my height is drawn. But, you know, this side could be the base as well if we had the height drawn perpendicular to there. So the base is just going to be the side where we have the height drawn perpendicular to it. Let's look at some examples. Okay, so in this first one, we have a right triangle with lengths of 14 and 48. So, you know, the base is, it doesn't matter, they're interchangeable, but I'll call the base 48 and the height 14. And so base times height divided by 2, just my calculator, 14, I'm sorry, times 24, 336. Now to get the perimeter, we need to find this side, so that would just be Pythagorean theorem. 14 squared plus 48 squared equals c squared. I believe this is a Pythagorean triple, but it is not one that I remember. So 196 plus 2304 equals c squared. So 2304 plus 196 is 2500. I knew it. And so when you take the square root of 2500, it is 50. So that is a triple, but it's not one that I typically remember. But the perimeter now is we just add 50, 48, and 14. So that's 112. Okay, so the quick check. This one is a triple that maybe you can remember, but if not, it's going to be 7 squared plus b squared equals 25 squared. So we get 49 plus b squared equals, 625, I believe. Sorry. Thing wants to work. And then 625 minus 49 is 576. And so the square root of 576 is 24. Okay, so they're going to use a lot of triples here to make it easy for us, but you can't always assume that. So the base is 24, the height is 7, so base times height divided by 2. So I get 84. And then the perimeter, we're just going to add 7, 25, and 24, and we get 56. Okay, that would be your perimeter. Okay. So example 2. Okay, on this one, you can look at it. We have base. We have a couple different triangles here. We actually have 3 different triangles. So we can use the base of this triangle as being 21, and the height is 8, and we can find the area of that whole triangle. So that would be base times height divided by 2. So 21 times 4. It's going to be 84. But now for the perimeter, we're probably going to have to, split this up a couple ways. Okay, so here we have a right triangle that's 6 and 8, so that's a triple, and that would be 10. And then we need to look at this triangle. Okay, so this is 8. I kind of erased that. It's hard to see. And now, how far is it from here to here? we need 21 minus 6, and so that would be 15. So now, I think this is a triple as well, but 8 squared plus 15 squared is equal to c squared. You can get 64 plus 225 equals c squared, and then let me it's 289. So 289 is equal to c squared, and the square root of 289 is 17. Okay, so the perimeter is we have one side that's 17, one side that's 10, and one that's 21. So that's 31, 48. So you might have to break it down a little bit to get all the different components. Okay? Now, very similar one here. The difference here is we have still the 3 triangles, but on this one, you'll have to use Pythagorean theorem to find this. It is a triple, so that's going to be 5. And then look at the other one over here. This is also a triple. You can do Pythagorean theorem. I'm just going to go ahead and tell you this would be 9. Okay, and so now we have our base, which is 5 plus 9, or 14 for the base, and our height is 12. So 14 times 12 divided by 2. 14 times 6 is 84. And then the perimeter, we're just going to add 13, 15, and 14. I think it's 42. Okay, and I can see on the next, when I see the words exact and approximate, we're going to be using some special right triangles again. So on this one here, let's see what we have given to us. Actually, I don't see a special right triangle, but I do know that I'm going to have to use a radical. So what I do see is this is an isosceles triangle because the sides are the same. If you draw the height in an isosceles triangle, it bisects the base. So if this is 2, this is 2. So we have a right triangle with measurements of 2 and 6. So if you do 2 squared plus, we'll call the height b squared, and set that equal to 6 squared, you're going to get 4 plus b squared is equal to 36. If you subtract 4, you get b squared is equal to 32. So b is the square root of 32, and they want us to simplify that. You can rewrite 32 as 16 times 2, or the square root of 16 times the square root of 2. And what's the square root of 16? It is 4. So kind of a lot of work to get the height, but b, or the height here, is 4 times the square root of 2. Once you have that, we're just going to fill in the blanks. Okay, the base is 4, because it's this whole thing, and the height is 4 to the square root of 2. Base is 4, height's 4 to the square root of 2. The area then, let's do that first, is base times height divided by 2. You're just going to multiply 4 times 4, 16, and divide by 2, and you'll get 8 square root of 2. And then the perimeter is 6 plus 6 plus 4. That's 16. And then for these here, the approximate, you're just going to use your calculator. 4 times the square root of 2 is approximately 5.7. And 8 times the square root of 2 is approximately 11.3. Okay, so they are going to want us to try and simplify some radicals here. On this next one, I recognize a special right triangle. So I'm not sure if y'all do or not. You've got 2 measurements there, and you can do a squared plus b squared is equal to c squared to find that side. Well, let's do that, actually. Let's just do a squared plus b squared equals c squared, and see what happens. 5 squared plus 5 to the square root of 3 squared equals c squared. So this is going to be 25. Now you can use your calculator for that, or let's do it here. 5 to the square root of 3 times 5 to the square root of 3. That's going to be 5 times 5 is 25. The square root of 3 times the square root of 3 is 3, and 25 times 3 is 75. Okay, and so you get 100 is equal to c squared, so c is equal to the square root of 100, which is 10. Okay, so the reason that I recognize that was 10 right away, so let me just show you here. I see a right triangle that has a measurement of x and x to the square root of 3. So I know that this side has to be 2x. That is a 30, 60, 90 triangle. But you could have just as easily done Pythagorean theorem and found 10. So our base, these are going to be congruent. This is 5, that's 5. Okay, so the base is 10. The height is 5 to the square root of 3. The area is base times height divided by 2. 50 divided by 2 is 25 times the square root of 3. Okay, and then the perimeter is, this is an equilateral triangle if you didn't recognize that. It's 30. And then for the approximate answers, we just use our calculator. Let's see, 5 times the square root of 3 is 8.7. And 25 square root of 3 is 43.3. Okay. So that is an equilateral triangle. Let's see what's next. See how many are left. We still have quite a few. So let's do one more. Example 4. What I notice here is that I have a isosceles right triangle, x and x. So if you have a right triangle that's isosceles, this is going to be a 45, 45, 90 triangle. So you have to recognize that. Or you could solve it Pythagorean theorem, but that would be a squared. You would do a squared, which is x squared, plus x squared equals 10 squared. And you would get 2x squared equals 100. Divide by 2, you get x squared is equal to 50. So x is equal to the square root of 50, which can be rewritten as 25 times 2. And so it's 5 to the square root of 2. But hopefully you'll just start to recognize on a 45, 45, 90, if the diagonal is 10, or if the hypotenuse is 10, then this side is going to be half of 10 times the square root of 2. So we have a base, 5 to the square root of 2. The height is also 5 to the square root of 2. I think this is 7.07 if you put it in your calculator. And then the area is base times height divided by 2. So 5 times 5 is 25. Square root of 2 times the square root of 2 is 2. So this is 25 times 2, 50 divided by 2, 25. And the perimeter here, now here's something new. When you're adding these up, 5 in the square root of 2 and 10 are not like terms. 5 in the square root of 2 and 5 in the square root of 2, you can add those. So this will be 10 plus 10 to the square root of 2. You cannot, they're not like terms, you can't add them together. And if you put that into your calculator, it would be approximately 10 plus 10 square root of 2 is 24.1. Okay, I'm going to stop the video here and we'll finish with part 2.